Let's add in the devices to the OSI model. At the physical layer, we have a device called a repeater. The repeater addresses an issue called attenuation. Attenuation is the loss of a signal over a distance. We'll call the repeater Pete. Pete's dumb, y'all. Pete only understands whatever comes in is what goes out. Garbage in, garbage out. The only thing Pete understands is layer 1 information. Remember that at layer 1, all we have available is bits. All we have is those electrical signals coming in, ones and zeros. Pete only understands those bits, garbage in, garbage out. So whatever Pete receives is what Pete repeats. Pete rebuilds or regenerates the signal that comes in and sends it out of the other side. He has no ability to make any decisions as far as where traffic is actually going. Pete's got a brother. We'll call him Hubba Bubba, the hub. Hubba Bubba is Pete's big brother. The hub is a multi-port repeater. Just imagine Pete's got multiple arms now. Still doing the same things, still making the same decisions, which actually is no decisions. Garbage in, garbage out. Whatever comes in is what goes out. The hub's also dumb. Pete and Hubba Bubba, they're dumb. All they understand is these electrical signals. If it's a 1, it's a 1. If it's a 0, it's a 0. Whatever comes in is what goes out. The layer 1 devices are dumb. They don't have any decision-making ability. All devices attached to a hub are in one collision domain. One big collision domain. Because the way the hub operates is any traffic that comes into the hub, say for instance it comes in from device A here, it's going to device C, comes into the hub here, and it's going to be sent out of all ports other than the one that it came in on. This is called repeating. The traffic comes in, or the bits come in to the hub, and the hub simply repeats those bits out of every port other than the one that it came in on. This brings up the topic of LAN segmentation. LAN segmentation occurs when we want to divide these collision domains, make these collision domains smaller by decreasing the number of devices in any given collision domain. With all the devices in one common collision domain, the more devices that you add to the network, the more potential there is for collisions or excessive collisions. In order to address the issue of excessive collisions, we go to layer 2, where we have the bridge and the switch. Bridges and switches make decisions based on MAC addresses. Whereas the hub and the repeater were dumb devices which had no ability to make actual decisions, the bridge and the switch makes a decision based on the destination MAC address, determining exactly what port to send the frame out of. Each port on the switch is a separate collision domain. However, all ports are still in one common broadcast domain. This can bring up a problem called excessive broadcasts. The larger your network gets, if all devices are still in that one common broadcast domain, that means every device on the entire network, each time a broadcast is sent out, each device would have to take up CPU time to discard frames that aren't even intended for that device. In order to address the problem of excessive broadcasts, we break the network into multiple broadcast domains. This is the concept of hierarchical networking. This brings us to layer 3. At layer 3, we use routers to create multiple broadcast domains, or to route between multiple broadcast domains. The purpose of a router is to route packets from one network to another. or to route packets from one broadcast domain to another. Routers do this by using a routing table. The routing table contains IP addresses, or actually network addresses, associated with interfaces out of which to forward the actual packets. So that gives us a basic feel for the devices at the lower layers. At layer 1, we'll use a hub to connect multiple devices together. However, all devices are still in one common collision domain. To address the issue of excessive collisions, we go to layer 2, where we find the switch. Each port on the switch is a separate collision domain, and the switch uses MAC addresses to make decisions as far as how to forward the frames to the appropriate devices. However, all devices are still in one common broadcast domain. This brings us to layer 3. In order to address the issue of excessive broadcast, we go to layer 3, where we find a router that routes packets between networks from one broadcast domain to another.